What is ecology? Ecology is the one branch of science which studies the interrelationships between organisms and their environment. In recent years, many ecologists have been paying special attention to the impact of humans on the environment. One reason is that we have ignored the laws which govern the natural world. We have broken the cycles of life. In addition, for the first time in history, we are producing synthetic materials which never before existed in nature. Such things as pesticides, plastics, smog, and radioactive wastes which remain deadly poisonous for tens of thousands of years. For these reasons, the study of ecology has become critically important. For we can learn from studying the natural environment ways to inhabit the earth without destroying it. One of the men most concerned with these problems is Dr. Barry Commoner.
The dictionary definition of ecology is simple enough, but what does it mean to say that organisms interact with each other and with their environment? It means that no organism can survive alone, that every species depends for its food on other living organisms. It means that as each species finds its own place in the environment, it modifies its environment, and in doing so, affects other species. It means that one organism's waste is taken up by another as food. It means that nothing dies without serving some other life. These relationships are bewildering in their variety, yet they follow definite patterns. Everything that we do on this earth depends on the environment that supports us. If we are to survive, we must understand its patterns, how it works.
To help us understand these patterns, Dr. Commoner has devised what might be called the 4 principles of ecology. A forest is an elaborate network of living and non-living things. Ecologists call this network a natural system. Most natural systems are in a state of balance or equilibrium. But if something stresses one part of the system, the entire system will react. Natural processes will compensate for this stress and bring the system back into balance. Above Los Angeles is a national forest which endures a particular type of stress. Every day, the forest is blanketed by thousands of tons of air pollution. Various teams of researchers are trying to trace how this pollution is upsetting the balance of the entire system. Through their studies, they hope to be able to predict the long-term future of the forest.
In order to predict what will happen to the forest, we have to monitor the major species in it over a period of time. For example, one study is looking at the organisms in the soil. These organisms decompose the dead needles and leaves, returning the nutrients in them back to the soil. To learn more about these organisms, our researcher takes samples of the soil at the base of specially numbered trees. At the same time, we have been making a continuous record of the health of these same trees, paying special attention to how well they keep their needles. The amount of dead needles and leaves at the base of the tree affects how water penetrates the soil. So another researcher regularly measures the amount of water in the soil. The water, in turn, will have an impact on whether the organisms in the soil are active or not. So our soil researcher tries to get some measure of this activity. He seals a sample of leaves and needles in an airtight chamber. By measuring the changes in a particularly sensitive chemical, he can get a reading of how rapidly these organisms are decomposing the needles and the leaves. In this way, we can slowly put together the information we need to understand the connections between the organisms in the soil, the water in the soil, and the health of the trees. We are also looking at the animals in the forest, such as the western gray squirrel. The squirrel likes to feed on the cones of the pine trees. Here is a fresh cone beside a cone that has been eaten by the squirrel. To get some measure of the impact of the squirrel on the forest, we go around to each of the study trees and count the number of cones the squirrel has eaten and scattered around the base of the tree. We combine this information with the population studies we have done on the squirrel and with the cone studies we have done on the trees, and we can begin to understand the relationship that exists between the trees and the squirrel.
But the squirrel, like all the species in this study, is only one member of the vast forest community. Each member is important because each contributes in some way to the balance of the whole system. And anything that happens in one part of the system will have some bearing on the overall balance of the forest. Because in natural systems, everything is connected to everything else. In natural systems, there is no such thing as waste. Nothing is thrown out. And since no materials are thrown out, they are always somewhere else in the environment. Take water as an example. We'll begin with water that falls as rain and trace how it moves through the environment. Once it has fallen, it might be taken up by the roots of a plant and transpire from the leaves back into the air. Or it may stay in the ground or travel through streams and rivers on its way to a sea, to fall once again as rain. Thus, the water has been cycled. Let's take another example, nitrogen. Most nitrogen is found in the atmosphere. As a gas, it cannot be used by most species directly, although all living things need it. In the soil, however, are certain bacteria which can use this nitrogen directly. They combine the nitrogen with other atoms. These nitrogen compounds are finally converted into a form that can be taken up by the roots of plants. These compounds travel through the plant and are used to make proteins and other vital parts of the organism. Plants, in turn, become food for animals. The nitrogen passes through the animal waste, and back to the soil, where the cycle is completed. Thus, nitrogen is cycled and recycled. In natural systems, all resources are cycled. There is no such thing as waste. Everything goes somewhere.
During the long course of evolution, natural processes have worked out the best kinds of relationships to each other. These relationships sustain complex natural systems in which all the resources are cycled and recycled. As an example, consider nature's treatment of dead organic material, shown here through time-lapse photography. In a matter of days, insects recycle the material contained in the body of the rabbit back through the environment. In the same way, the waste of an animal becomes the nutrition of the soil. This occurs because hundreds of thousands of microscopic bacteria decompose the waste, breaking it down into simple compounds. These compounds become food for plants, and these plants, in turn, nourish the animals which eat them. Nature's treatment of waste is to recycle it back through the environment, a treatment developed after billions of years of trial and error. Consider the Department of Sanitation's solution to the same problem. Normally, organic waste is piped to special sewage treatment plants where it is treated and flushed into a body of water. In the water, these nutrients become food for algae. So as more and more waste is dumped into the water, the population of algae increases. When algae grow too thickly, they tend to die. Then, they become food for certain kinds of bacteria which consume oxygen in their life processes. And a chain reaction can be set into motion whereby the huge number of bacteria feeding on the algae can exhaust the oxygen in the water, suffocating some forms of life. In his treatment of waste, man has failed to imitate nature. Nutrients from the soil are not returned to the soil. A natural cycle is broken.
Everything man does has an effect. Every technological advance carries some kind of price tag. As an example, let's look at the automobile. Since the Second World War, cars have increased in size, have bigger engines which operate at higher temperatures, and have more accessories like power steering, power brakes, and air conditioning. Yet these technological improvements are not free. In the same period of time, the number of vehicles has increased by 170%. The number of miles traveled by 180%. The population by about 50%. Yet the amount of a deadly air pollutant, nitrogen oxide, has increased by about 630%. This pollution is the price we pay for larger, more powerful automobiles.
In our study of the effects of air pollution on this forest, we have been able to draw some tentative conclusions. For example, we can see the direct effect smog has on the oak leaf and also on the pine. When I first began to study this forest about 15 years ago, I took some photographs of several trees. This is the same tree, taken from the same angle, after about 15 years of exposure to smog. We believe that as injury to the tree increases, the older needles will not stay on the tree, but will fall to the forest floor. This, of course, affects the number of needles and leaves at the base of the tree, and consequently on the organisms in the soil. We also know that trees that have been weakened are very susceptible to attack by the bark beetle. Once the beetle gets into the tree, it will kill it. Also in this forest, There is a type of fungus which attacks the seeds and the seedlings of the pine tree, killing them. It seems that smog causes a higher percentage of infection by this type of fungus. Each day as smog fills the air, this forest, which took thousands of years to develop, is slowly dying.
This forest is dying because the car we drive today pollutes much more than its pre-war counterpart. Yet these changes in the technology of the automobile are part of a pattern of changes that have occurred since the Second World War. Virtually without exception, each change has placed more stress on the environment, has required huge increases in the consumption of energy, has been wasteful of resources, and has come to rely more and more on oil. For example, we use oil to make polyester, and we use polyester to make clothing instead of using renewable fibers like wool or cotton. Today, we use petroleum products to make fertilizers instead of rotating crops or using manure as we did 30 years ago. Today we use oil to make plastics, and we use plastics instead of renewable materials like ceramics, glass, steel, leather, and wood. We've seen how, in natural systems, no change occurs without some consequence. We have to understand these consequences in order to design our technology to be more compatible with the environment. For if we are going to survive, we must conform, like all living creatures, to the principles that govern how the environment works.
Why do we need to understand the laws of the environment? I think the answer is that this is the only place that we have to live. And we've got to know how it works so that when we do all of the things that we do on this earth, produce goods, set up economic systems, relate to each other, that we keep in mind that whatever we do, we must not violate the principles on which the environment works.